Good day, ma'am. I am Ron Michael Nene, and today I am going to discuss spread spectrum techniques. So, there are four basic types classified according to the point of insertion of PN code. So, the first one is direct sequence spread spectrum, or also known as DSSS. Then, frequency hopping spread spectrum, or also known as FHSS. Then third is time hopping spread spectrum, THSS. Then last one is a chirp spread spectrum, or also known as CSS. So the first one, direct sequence systems, or also known as DSSS. It uses a locally generated pseudo-noise code to encode digital data to be transmitted. The speed of the code sequence is called the chirping rate, which is measured in CPS. The amount of spreading is dependent upon the ratio of chips per bit of information, which is the process gain GP for the SSS. A direct sequence modulator is then used to double sideband suppress carrier, modulate the carrier frequency to be transmitted. The resultant DSB, suppressed carrier AM modulation, can also be thought of as binary phase shifting shift key or BPSK. At the receiver, the information is recovered by multiplying the signal with a locally generated replica of the code sequence. The effect of multiplication of the spread spectrum signal RXB with the PN sequence PNT used in the transmitter is to despread the bandwidth of RXB to RS. If PNR is not equal to PNT, then there is no spreading action. The signal DR has a spread spectrum. A receiver not knowing the PN sequence of the transmitter cannot reproduce the transmitted data. It will basically produce yet another version of the spectrum spread of the original signal with a different code. The multiplier outcome becomes DR is equals to RXB multiplied to PNR is equals to DT multiplied to PNT times PNR. For BSK modulation, the building blocks of a DSSS systems are shown in the PowerPoint. So this is what a direct sequence systems looks like. Frequency hopping systems, or FHSS. Carrier frequency shifting is discrete increments in a pattern dictated by a code sequence. The transmitter jumps from frequency to frequency within some predetermined set. The order of frequency usage is determined by a code sequence. A frequency hop system, unlike the direct sequence one, can use both analog and digital carrier modulation and can be designed using conventional narrow band ratio techniques. A pseudo-noise sequence PNT generated at the modulator is used in conjunction with an M-ARY FSK modulation to shift the carrier frequency of the FSK signal pseudo-randomly at the hopping rate RH. The transmitted signal occupies a number of frequencies in time, each for a period of time th, open parenthesis, equals to 1 over RH close parenthesis, referred to as dwell time. FHSS divides the available bandwidth into n channels and hops between these channels according to the PN sequence. The transmitted bandwidth is determined by the lowest and highest hop positions and by the bandwidth per hop position. So this is how an FH, or rather a FHSS block diagram looks like. Next is the time hopping systems, or THSS. A time hopping system is a spread spectrum system in which the period and duty cycle of a pulse RF carrier are varied in a pseudo-random manner under the control of a coded sequence. Time hop spread spectrum systems have found no commercial application to date. However, the arrival of cheap random access memory, or also known as RAM, and fast microcontroller chips make time hopping a viable alternative spread spectrum technique for the future. Time hopping is a system in which burst signals are initiated at pseudorandom rate. In this, the transmitter is switched on and off by a code sequence. The main difference between a frequency hopping and time hopping system is that in the former, the transmitted frequency changes at each code chip time. In the latter, rather, the frequency changes occurs only at 0 or 1 transitions in the code sequence. And this is how a transmission of the HSS looks like. And this is how the THSS receiver looks like. Then finally, the chirp spread spectrum, or also known as the CSS. Chirp spread spectrum, or CSS, is a long-range radio frequency technology for wireless communication that can be leveraged to detect and track the location of people, assets, and devices both in and outdoors across large-scale facilities. Chirp technology increases the bandwidth of signal to multiplies of the value stated in the Shannon-Hartley theorem, helping it enable communication more robust against interference. Chirp was designed to operate in the 2.45 GHz ISM band and belongs to the same category as other spread spectrum technologies, using a wideband modulation technique that creates linear frequency modulated signals, also known as chirps. And this is how a chirp spread spectrum CSS looks like. For the T measured, it is the time of flight measurement. The T response is the measured time of response, and the T underscore P is the propagation time between device A and B. And that will be all. Thank you for listening.